So after sketching the two graphs, we found that r equals 1 plus 2 sine theta. The loop of it goes through the origin. With that, we found that r can equal 0, and we can move the equation around to make sine theta equal -1/2. With that, we find that that also equals 7 pi on 6 and 11 pi on 6. So testing these 2 points, we find that theta lies between these 2 points.
To find the points of the where both of these curves cross the x and y axis, first we'll take each equation separately and separate it into its x and y components. So what we'll do for this first equation, r equals 1 plus 2 sine theta, we'll first solve for the x-axis. And on the x-axis, theta will equal 0 and pi. So we'll sub those two values in to find the value of r, and this will be the points where it lies on the x-axis. So we found by subbing in 0, it'll cross the point at 1 and 0. And we'll find that when we sub in pi, we'll find that it crosses at -1 and 0. And then same for the y-axis, we'll sub in pi on 2 and sub in 3 pi on 2. So that's the 90 degrees and the 270 degree axis. We found for the first one it equaled r equaled 3. So it's 3 in the positive y direction, so it crosses at 0 and 3. When we subbed in 3 pi on 2, we found that it was -1 in the 270 degrees, or the 3 pi on 2 direction, which means it went up 1 unit, so it crosses at 0 and 1, which coincides with our graph up here. We did the same for the bottom one. We found that no matter what you subbed in, so when you subbed in 0 and pi again, like we did up here, crossed both at 0 and 0, which is the origin, which coincides with what we wrote up there. And down here, for the y-axis, we subbed in pi on 2, and we found that it came in at 4. And then when we subbed in our 3 pi on 2, we found that it came in at -4, but because it's in the 3 pi on 2 direction, it was up +4, so it crossed at 0 and 4 again.
So here we're trying to find the points of intersection across the two curves here. So what we do is we equate both of these, which we've done here, and solve for theta. And here we've got theta equals pi on 6 and 5 pi on 6. We then substitute it back into either equation, it doesn't matter, we'll still get the same points. So we sub it into 4 sine, and here we've got pi on 6, which gives us 2. And again here, 5 pi on 6, which also gives us 2. So then in polar form, we've got these 2 points, which are graphed here. And then converting it into Cartesian form so that we can get a better understanding of where those points are, looking at the graph and then using sine and cos, we've found that -√3 and 1 and √3 and 1 are the points in which they intersect.